Hello 8th graders and happy Monday. Today we're going to do part 2 of the Unit 2 test review. I know you're going to do a great job. Let's dive right in. This unit was all about dilations and similarity. Remember, two figures are similar if one can be mapped to the other using a dilation, a reduction or enlargement, and rigid transformations. Similar figures have sides that have been reduced or enlarged by the same scale factor. And similar figures have congruent angles. All of the angles are exactly the same. So let's look at an example. Which series of transformations would map ABCD to GHFE? Well, would it be a rotation of 90 degrees counterclockwise and a dilation by a scale factor of 2? A rotation of 90 degrees counterclockwise and a dilation by a scale factor of 1/2? A reflection over the y-axis and a dilation by a scale factor of 2? Or a reflection over the y-axis and a dilation by a scale factor of 1/2? First, as I'm looking at these choices, to get from ABCD to GHFE, is it an enlargement or a reduction? It's a reduction, so I know that my scale factor is going to be a fraction less than 1. So I know that A and C cannot be correct answers. So what is the correct answer? It's B. This shape can be obtained by rotating 90 degrees counterclockwise and then dilating by a scale factor of 1/2. Are the two figures similar? Yes. These two figures are similar because one can be mapped to the other by a series of transformations. Are these two triangles similar? How do you know? Go ahead and answer this question now. Yes, these two triangles are similar because they have congruent angles. Remember, in similar figures, all angles are congruent. We also practice drawing dilations, both with centers at a point on the figure and with centers at the origin. Let's look at an example. Draw the dilation of the triangle with a scale factor of 3 and a center of dilation at S. First, what's the length of ST? ST is 4 units. What's the length of SR? SR is 1 unit. Now, to draw a dilation with a scale factor of 3 and a center of dilation at S, each point is going to enlarge or move away from S on a straight line. When I have a scale factor of 3, what will be the length of S prime T prime? It will be 12. 4 times 3 is 12. What will be the length of S prime R prime? It will be 3. 1 times 3 is 3. I can use that knowledge to draw the dilation. Go ahead and do that now. Check to see that your dilation looks like mine. We can also draw reductions. Draw the dilation of the quadrilateral with a scale factor of 1/4 and a center of dilation at F. So first, what is the length of CD? What is the length of the two horizontal sides? It's 8. What is the length of CF? What is the length of the two vertical sides? It's 12. To find the length of the new sides after the reduction, I need to multiply by my scale factor of 1/4. So what will be the length of C prime D prime? It will be 2. 8 times 1/4 is 2. What will be the length of C prime F prime? It will be 3. 12 times 1/4 is 3. Now, Keeping point F the same, I can go ahead and graph my new points to draw my dilation. Do that on your paper now. Check to see that your dilation looks like mine. I can also dilate figures about the origin. When I do that, I can multiply each coordinate by the scale factor. First, what is the location of point S, point R, and point T? S is located at 0, -2, T is located at 0, 2, and R is located at -1, -2. When I multiply by the scale factor of 2, what will be the new ordered pair for S prime, T prime, and R prime? S prime will be located at 0, -4, T prime will be located at 0, 4, and R prime will be located at -2, -4. Go ahead and draw those new points in now to draw your dilation. Check to see that your dilation looks like mine. We can also draw a reduction that's centered at the origin. Draw the dilation of the quadrilateral with a scale factor of 1/2 centered at the origin. First, we can find the original ordered pairs for each point. What's the location of F, E, C, and D? F is located at -8, 8. E is located at 0, 8. C is located at -8, -4. And D is located at 0, -4. After a dilation by a scale factor of 1/2, what will be the new ordered pairs for F prime, E prime, C prime, and D prime? F prime will be located at -4, 4. E prime will be located at 0, 4. C prime will be located at -4, -2. And D prime will be located at 0, -2. Go ahead and draw those new ordered pairs in now to draw your dilation. Check to see that your dilation looks like mine. We also practice finding missing sides and angles in similar figures. Remember, similar figures have sides that have been enlarged or reduced by the same scale factor. And that similar figures have congruent angles. So let's look at some examples. The two figures are similar. What is the value of the question mark? Well, go ahead and try to fill that in now. The question mark corresponds to either one of the acute angles in our figure, so the answer is 72 degrees. The two figures are similar. What is the value of t? Well, first, what's the scale factor to go from the shape on the left to the shape on the right? It's 2. 5 times 2 is 10. Now I can find t. What's the value of t? T is 2 millimeters. 1 times 2 is 2. Let's do another. What's the value of z? First, what's the scale factor to go from the shape on the left to the shape on the right? It's 1/2. 6 times 1/2 is 3. So what's the value of z? It's 1. 2 times 1/2 is 1. Let's do another. What's the value of the question mark? It's 73 degrees. We also talked about how we could use the ratio between the sides of similar triangles to solve for missing sides. The two triangles are similar. What is the value of y? Well, it's going to be hard to find the scale factor to go from 5 to 8 15/100ths. So I can look at the ratio of the sides. 10, the medium side, is 2 times as long as 5. So I know that y, the medium side, will be 2 times as long as 8 15/100ths. What's 8 15/100ths times 2? Well, 2 times 5 is 10. 2 times 1 is 2, plus 1 more is 3. 2 times 8 is 16. The length of y is 16 and 30 hundredths. Let's look at another example. Find x. Well, here I can see that the long side, 15, is 3 times as much as the short side, 5. So x will be 3 times as much as 8 and 15 hundredths. Go ahead and find the value of x now. X is 24 and 45 hundredths. Now try one on your own. The two triangles are similar. What is the value of x? I can see that the medium side is 2 times as long as the short side. So x will be 2 times as long as 3 2/10. X is equal to 6 4/10. We also talked about finding the slope of lines in this unit. The slope of a line can be calculated by writing the vertical change over the horizontal change. Rise over run. Slope can be calculated using the equation m equals y2 minus y1 over x2 minus x1, the change in y over the change in x. So, let's look at a few examples. What is the slope of this line? The vertical change is 6. The horizontal change is 4. When I simplify, the slope of this line is 3/2. What is the slope of the next line? The slope of the next line is 2. 2 over 1, or 2. What is the slope of the next line? The slope of the next line is 1/2. We also talked about calculating slope using the equation m equals y2 minus y1 over x2 minus x1. We can plug those values in to find m. In this case, y2 is 5 and y1 is 1. x2 is 7 and x1 is also 1. What's 5 minus 1? It's 4. What's 7 minus 1? It's 6. Can I simplify 4 over 6? Yes. What's the largest number that goes into both 4 and 6? It's 2. What is my new simplified fraction? It's 2/3. The slope of this line is 2/3. What is the slope of the line through 1, 1 and 5, 7? Remember, I can use the formula m equals y2 minus y1 over x2 minus x1. The slope of this line is 3/2. Try a couple more. What is the slope of the line through 2, 5 and -1, 2? Remember, we can use the formula m equals y2 minus y1 over x2 minus x1. So I can subtract 2 minus 5 over -1 minus 2. What's 2 minus 5? It's -3. What's -1 minus 2? It's also -3. So what's the slope of the line? It's 1. Any number divided by itself is 1. Now you try one. What is the slope of the line through 2, 5 and -7, -4? The slope of the line is 1. We also talked about writing equations of lines. Remember that slope is the steepness of a line or its rate of change. It's represented by the letter m. Slope can be found by dividing the vertical change by the horizontal change and writing the result as a fraction. We can also use the formula m equals y2 minus y1 over x2 minus x1. The y-intercept is the coordinate when x equals 0, or the point where the line crosses the y-axis. The equation of a line can be written in slope-intercept form. Y equals mx, slope times x, plus b. To find the equation of a line, we can find the slope and then plug in x and y to solve for b. When we have a line, we can identify the slope and the y-intercept to write the equation of the line. What's the slope of this line? It's 2. What's the y-intercept? It's 4. Now write the equation of the line in slope-intercept form. Y equals 2x plus 4. A line passes through the points 1, 3, and 2, 5. What's the slope? Remember, I can use the formula m equals y2 minus y1 over x2 minus x1. Go ahead and find the slope now. The slope is 2. I can plug into the slope-intercept formula y equals mx plus b to solve for b. So y equals 2x plus b, or 3 equals 2 times 1 plus b. Go ahead and solve for b now. B is 1. So what is the equation of the line? Well, y equals 2x plus 1. You've done a great job with this video. Now it's time to go to IXL Practice Y.10.